Hey everyone, welcome back. It's me, your boy Abhi here, and in this video we are diving into a question from differential equations and let's see how to solve it step by step. So the question we are having here today is y double prime over y prime minus y prime over y, and this is equals to the natural log of y. So the first step we are going to do here is just have that common denominator here, so we'll have y dot y double prime minus y prime squared, which is equals to y times y prime times and natural log of y. So in this case we can now do a substitution here. Let's take as y prime equals to u. So differentiating both sides with respect to x, we get d2y by dx squared, which is clearly y double prime equals to du by dx. So now I'm going to multiply by dy. So let's put du over dy times dy by dx indeed. So we know that dy by dx is actually u, so we can substitute back here. So what we can have here for y double prime is actually u times du by dy. So don't forget that. And the substitution we had is y prime equals to u. So now the equation becomes, so y times u times du by dy minus u squared equals to y times u times natural log of y. So we can clearly see that we can cancel one u from each of the following, and final equation can be simplified as y times du by dy minus u equals to y times natural log of y. We can actually divide both sides by y, so finally we get du by dy minus 1 over y times u and natural log of y. So in that case we can actually multiply by 1 over y again, so from the both sides, and we can have 1 over y du by dy minus 1 over y squared and u and natural log of y over y. So we can clearly see that this is just the derivative of 1 over y times u indeed, so which is equals to natural log of y over y. So integrating both sides with respect to y, we get d over dy times 1 over y times u is equals to, terribly sorry about that, I forgot to put dy there, is equals to natural log of y over y times dy indeed. So this cancel each other out, and finally we have for this side is just u over y is equals to, well, this is just the easy integration. So what we can have here is we can just write natural log of y and d log of y, which is equals to natural log of y squared over 2 plus a constant. Maybe we can take as a square over 2. Well, this could be a little pretty one though. So let's move on to page number 2. So the final equation we have here is u over y is equals to ln squared over 2 plus a square over 2. So rather than writing c as an arbitrary constant, we can even write a square over 2. This is also an arbitrary constant, so that's not the big deal. So okay, now we can write this as u equals to y over 2, take the common out, so natural log of y squared plus a squared. Pretty cool, right? So now we have for u, but u is actually what? Dy by dx, correct? So 1 over y times natural log of y squared plus a squared dy by dx is equals to 1/2, right? So I'm actually separating the half other side and taking all other y variables this side. So I hope it's clear for everyone. And next, we can integrate both sides with respect to x to find the final result. So 1 over y times natural log of y squared plus a squared dy by dx times dx is equals to half times dx. And we can clearly see that this will cancel each other out. And this is a PC, and this is also a pretty neat integral. We can actually do the same as d natural log of y over natural log of y squared plus a squared. That doesn't look like a 2 though, but pretend to be as 2. I hope you guys get it though. So, and this side we are having x by 2 plus an arbitrary constant. We can even take like b over 2. Who's gonna judge us, right? To integrate this, we can actually see that this is of the form of, we know that maybe dx over x square plus a square is just the tangent inverse, no? So 1 over a tan inverse x over a, right? Plus constant. So this is the actually format we have here, so we don't have to be worried. So final answer we can have here is just 1 over a times tan inverse of natural log of y over a, which is equals to x by 2 plus b by 2 indeed. So now we have to separate the y variables again. So here, let's take the a outside and half, so it will become a by 2 times x plus b, and of course we have be the tan inverse will be this side, so I'm going to take this as well. So natural log of y over a, which is equals to tan of a over 2 times x plus b. Now let's move on to page number 2. Sorry, it's actually 3, right? Silly me. So the next thing we have to is separate the y. So y equals to, let's multiply by a, we get a times tan a by 2 x plus b, and we have the natural log, so we just have to put right this all in the power of e, so which is equals to y. So what we have here is the final answer for the differential equation we just solved, which is y equals to e to the power a times tan a by 2 times x plus b. I hope you guys enjoyed this video right now. Be sure to like and subscribe. See you in the next video. Until then, bye bye from Abhi.